So here's the interference, or the two-source interference packet from the book. Following the directions here, we want to color code destructive and constructive interference, two different colors. I'm going to color code destructive red and constructive green with an open circle for troughs and a closed circle for peaks. So we go here and color code all of the intersections. Constructive interference for a peak is what we're going to have when a peak and a peak meet, so they add together constructively. So a place like that, or that. When I have two troughs add together, two troughs interfere, I'll have a bigger trough. So I have that. And then on the other side of the coin, destructive interference, I'll have when a peak and a trough meet. So like there, or there, or there. Okay, so we see the patterns here. Everywhere along this top line, there's all constructive interference. Sometimes it's a peak and sometimes it's a trough, but it's always big waves. Along these red lines, there's always destructive interference. So the water there, if this is water, would always be flat. So here we see again lines. We're not going to worry about what happens when we get too close to the bobbers, but that's what we see the overall pattern being. So here we're going to just draw those lines. We don't need to draw every dot, and we call them antinodal lines if they're constructive interference, or nodal lines if they are destructive interference, and we have a numbering system for those as described in the directions. So those are lines of constructive in the green and destructive in the red interference, and we have this ordering system. And it might seem a little arbitrary right now, but in a couple of pages we'll see that there's a really good physical reason for these order numbers. Here on the second page we have three different pictures of the bobbers with different spacings between them. We've moved the bobbers away from each other from top to bottom. I've gone and labeled all of the order number lines and the constructive and destructive interference, and the moving the bobbers away from each other has an effect on the pattern of lines. Two effects actually. There are more nodal and antinodal lines as the bobbers move apart, and they're spaced more closely together. So it's not just an effect of there being more space in between, more space between the bobbers to have more lines, but the lines are actually themselves spaced closer together. So we get, it grows at a pretty quick rate as we move the bobbers apart. Here the bobbers are the same distance apart. If you think that the bottom one is further apart, go ahead and check. It's an optical illusion. But they're moving differently. In the bottom one, the wavelength is smaller, so since I know that the wave speed has to be the same, I can conclude that the bottom bobbers are moving with a higher frequency than the top ones. If the wavelength is lower and the wave speed is the same, the frequency has to be higher, so that when I multiply it by the lower wavelength, I still get the same wave speed. So this again has two effects on the pattern, and again it's the effect of more lines and the lines being closer together. Okay, so here's where we put all this together and determine the cause of these patterns. First we're going to look at the number of wavelengths away from each bobber each of these 4 points are. So I have peaks in the dotted and troughs in the solid, so if I start at the bobber, that's a half a wavelength, now 1 full wavelength, 1.5. Point A is 2 wavelengths from the left. Maybe switch to green here. And from the right, half, 1, 1.5, 2 wavelengths. And this is 2 peaks adding together, so this is a point of constructive interference. Point B is a half, 1, 1.5, 2 wavelengths from the left, and a half, 1, 1.5, 2, 2.5, 3.5 wavelengths from the right. It is a point of destructive interference because we have a peak and a trough. Point D is 1, 2.5 wavelengths from the left, and 1, 2, 3.5 wavelengths from the right, and it is a point of constructive interference because it's 2 troughs. So we'll get a big trough there. Point C is 1, 2, 3, 4 wavelengths from the left, 1, 2.5 wavelengths from the right, and it is destructive interference because we have a peak and a trough. So this difference in travel distance is really the issue here. If I have these two waves are traveling different distances, this one traveled 2.5 wavelengths to get there, and this one traveled 3.5 wavelengths to get there. But when they get there, they're interfering constructively. They started out in phase, but they traveled different distances, and it just so happens that they came back into phase. In this one, this wave travels 2 wavelengths, and this wave travels 2.5 wavelengths to get there. And again, they started in phase, but because they traveled different distances to get to that point, there's destructive interference there. So that's what's happening here. And if you look at the difference in travel distance, like this one traveled 1 wavelength further, this one traveled 1/2 wavelength further. Let's look at these. This one traveled 0 wavelengths further. They traveled the same distance. This is 1 wavelength further. This is 1.5 wavelengths further. And this is 1.5 wavelengths further. This one is on the central line, which is m equals 0. This one, see, there's 0.5, there's 1. This one is on the m equals 1.5 line, and it traveled 1.5 wavelengths further. This one also is on the 1.5 line, and it also traveled 1.5 wavelengths further. This is on the m equals 1 line, and it traveled 1 wavelength further. So the order number is the difference in travel distance from the two bobbers. And that difference in travel distance is measured in wavelengths. So the big idea here is that if I'm on the m equals 2 line, the one of the waves has traveled 2 wavelengths further than the other to get there. I don't know, it doesn't tell me what the distance is, and every point along the line is a different distance. But if I'm on the m equals 2 line, I know that I'm 2 wavelengths closer to one than the other, and that tells me that those waves will always arrive in phase, so that'll be a place of constructive interference.